Hi everyone, welcome to the channel. In today's video, I'm going to be looking at an example of integration. So here we've got an integral of x squared times ln x. Now usually with integration, the biggest problem we have is actually figuring out what method to use in order to find the integral. So always the first thing when you're looking at an integral, you want to ask yourself, is this a standard integral? So that means, can you just do straightforward integration, no complications? So when we look at the example we've got here, you can see that it's not standard. Then you ask yourself, is this on a form that is on my formula sheet? So that means, is any part of this the derivative of another? So if I look at x squared, is x squared the derivative of ln x? No, it's not, which means that you're not going to find this on a formula sheet because you're sitting here with a product and the one is not the derivative of the other, which is usually the way the derivatives look on the formula sheet. So when you've got something like this, where you've got a product, you've got a function multiplied by another function, it means that you can use integration by parts. So the integration by parts rule says, if you have the integral of u v dash dx, that's going to equal uv minus the integral of u dash v. Okay, remember that the notation v dash is just the derivative of v, right? And u dash is just the derivative of u. And u and v are the functions that you choose from your integral. So that's the trick. We now need to figure out what are we going to use as u in order to find u dash, and what are we going to use as v dash in order to find v. Right? So that's the question. So when I look at the function I've got here, if I was to choose, let's see, say we choose u to be x squared. Say I choose u to be x squared, right? The derivative of that is fairly straightforward because it's just going to be 2x. Then I choose v dash to be ln x. How are we going to find v? That's the challenge, isn't it? Because you can't actually find the integral of x, of ln x, right? So you can't go backwards here, which means that this does not work. So instead, we are going to choose u to be ln x, which means that u dash is going to be 1 over x. That should be an x. And then we're going to choose v dash to be x squared, which means that v is going to be 1 over 3x cubed. And then we just plug the values into the integration by parts formula. So that means that our integral of x squared ln x dx is going to be equal to, it's u times v, so a third x cubed ln x minus the integral of u dash times v. So that is going to be a third x cubed times 1 over x dx. Then let's just simplify. That should be cubed. I can take the constant value out, and that is just going to be x squared dx and that'll be equal to a third x cubed ln x minus, what's that going to be, times 1 over 3x cubed plus our integrating constant. Right? You have to add the integrating constant in because what you've got here is an indefinite integral. And an indefinite integral is where you don't have limits. Once you have limits on your integral, you then would have to evaluate every part of that integral. And that is called a definite integral. So I hope this example was useful and helped you see a little bit clearer how to apply integration by parts. I'll see you next time. Bye.